Good day, students. Today, what we are going to learn is about percentage composition. In this video here, what I'm going to teach you is how to determine the percentage composition by mass of an element if you are given the compound. Now, in order for me to explain this concept to you, I like to explain it in the context of solving a question. Now, students, take a look at this question. My question to you is, what is the mass of oxygen in 50 grams of calcium carbonate, CaCO3? Students, you will agree with me that in order to find out the mass of the oxygen in 50 grams of calcium carbonate, you most likely will need a certain fraction. Okay? And if you take this fraction and you multiply it by 50 grams, okay, you will be able to get the answer, which is the mass of oxygen. Now, for the purpose of this lesson, let's just call this fraction, okay, that we're trying to understand, by fraction by mass. Let's just, for now, temporarily call it fraction by mass. Now, students, how then can we get this fraction? Now, let us begin by considering, instead of 50 grams of calcium carbonate, let us consider another case that you might be more familiar with. Let us consider, okay, 1 mole of calcium carbonate. Now, we know that 1 mole of calcium carbonate weighs, okay, 100 grams. How do I know this? Because, okay, students, let's recall molar mass. Now, 1 mole, okay, of calcium carbonate would have 1 mole of calcium, 1 mole of carbon, and 3 moles, okay, of oxygen. Now, based on the molar mass, you know that 1 mole of calcium, you can actually get this from your periodic table. 1 mole of calcium, okay, they weigh, sorry about that. Maybe I just, instead of using the word weigh, I will use the word have a mass of, have a mass of, for the calcium, 40 grams. For the carbon, 12 grams. For the 3 moles of oxygen, 3 times 16, which gives me 48 grams. If I were to add this value up, add this value up, 40 plus 12 plus 48, that will give me a total of 100 grams. Now, students, which means, right, you will know that out of this 100 grams of my calcium carbonate, out of this 100 grams of calcium carbonate, there is really only 40 grams from your calcium, 12 grams from your carbon, and 48 grams from your oxygen. Which means if I were to take a fraction of the mass, okay, of oxygen against the whole thing, it becomes 48, okay, because this mass here is from oxygen over the total of calcium carbonate, which is actually 100, okay, I would actually get this fraction, which is the fraction by mass. Now, if I take this fraction, okay, and I put it here, 48 over 100 times 50 grams, okay, what would I get? Well, I basically would get 24 grams, which means my answer to this question is that in 50 grams of CaCO3, calcium carbonate, I actually have 24 grams of oxygen. Now, students, in order, if you look with me through this explanation, you will realize that in order for me to get this fraction, what I have done was that I have taken the relative atomic mass of my oxygen, okay, relative atomic mass of oxygen, and what I did was I multiplied by the number of oxygen atoms. Okay, in this case here is 3. Okay, and I take the whole thing and I divide the whole thing by actually the molecular mass of my calcium carbonate, which is actually, as we have calculated over here, 100. So students, this, okay, is essentially that fraction by mass. But however, students, if I were to take this and I take this whole thing times 100, okay, this term, which I have called only in this video here because it's times 100, this whole thing here now has a name. As in your textbook 9.4, this is what we call the percentage composition. And to be more precise, students, it's percentage composition by mass. Now, take some time to think through this while I rewrite the equation for you. Based on this equation, if I were to rewrite this in a general sense, it would look something like this. Okay, so allow me to read this for you. Percentage composition of an element in a certain compound, okay, percentage composition of that element by mass is the relative atomic mass of that element multiplied by the number of atoms of element in the compound, okay, divided by the relative molecular mass of the compound, okay, remember, because it's percentage, we need to take the whole thing and then multiply the whole thing here, okay, multiply the whole thing here by 100, okay, and that, student, will give me the percentage composition by mass of that element, okay, in the compound. Now, student, this formula will work because, number one, you actually know the formula. Well, the formula tells us how many, in the example, oxygen there are and how many calcium there are. And this formula only works, okay, because you also know the relative atomic mass, okay? You know the relative AR of all the elements that makes up the compound. Now, if you will, I want you to try for me, okay, this question. I want you to determine for me, okay, the percentage, okay, composition by mass of oxygen in lead nitrate. Because the question asks for percentage composition, students, okay, because the question asks for percentage composition, your answer should be left with the units of percentage. So this, student, okay, is the video for 9.4 percentage composition. Thank you.